So let's try this example. So Baldo wants to fit a flower pot on a triangular container. To do so, he needs to find the area of the shaded region of this circle. He needs to find the area of this circle to create, okay, to fit a flower pot, okay, inside of the triangular container. So the shaded region is given by this yellow part, okay. Given that the triangular container is an equilateral triangle with a side measurement of 20 inches and the pot is tangent to the sides of the triangle, so we need to find the area of the shaded region below of this yellow part. So the question is, what's the area? What's the area of the yellow region? Okay, so how do we find the area of the yellow region? We only have one given, that the side measurement of the triangle is equal to, of the equilateral triangle is equal to 20 inches. So to solve this problem, we have to also know that this equilateral triangle is also equiangular. So this is 60, this is 60, and this is also 60. And then a we can create a new formula in finding the radius of this circle. So how do you find the radius of a circle that's been inscribed in a rectangular triangle, in a equilateral triangle? Okay, so for this problem, okay, so if you can see, guys, we can create, using the dotted lines, we can create three triangles. Okay, so what are the three triangles that we can create to find the area of the total triangle? So the area of triangle ABC is going to be equal to the area, okay, area of triangle AOC, okay, area of triangle AOC plus the area of triangle COB plus the area of triangle BOA. Okay, so this part, and then this part. Okay, so we found their areas. And since we know that each of these are triangles, therefore they all have a triangle formula for solving the for solving the uh, for solving the area of the given triangles that we have here. So what's the area of triangle AOC? Okay, so that's gonna give us 1/2 base times height. And we know that the base for this one, okay, we know that the base is equal to B. Yeah, so for this one, the base is equal to B. So this is B, small b, and then we know that the radius here is just the same for all parts. And since this is R and that's the height, so that's gonna be R. Okay, and then plus 1/2. Okay, so we're COB. So this is COB, and then we're given here that the base of triangle COB is equal to A times the radius, because again, that's the height, and then plus the area of triangle BOA. And we're given here the base. The base is equal to C, and then of course we have the height, which is equal to R. So therefore we can factor this term that we have here. So therefore this is going to be 1/2 multiplied by A plus B plus C multiplied by R. Okay, so that's the area of triangle ABC. And what do we have here, guys? So this is the perimeter, right? This is the perimeter of our triangle. And then we can divide that by 2. So if we're going to divide that by 2 or multiply it by 1/2 according to the equation that we've created here, we can create a much more simpler version of it. We can call it as S, or the semi-perimeter. Semi-perimeter. So the semi-perimeter of this triangle that we have here, of our triangle ABC, is going to be 1/2 A plus B plus C. And therefore, the area of triangle ABC is just going to be S times R, where S is your semi-perimeter. Don't get confused by the side. This is side measurement. This is side measurement. S for this one is semi-perimeter. S times R, where R is your radius. And then, so this is the area of the triangle, and we have the semi-perimeter and the radius. To solve for the radius, we just simply divide both sides by S. So therefore, the radius of that circle inscribed in a triangle, so that's the total area. Okay, we need to first find the area of the triangle divided by the semi-perimeter. So how do we find the area of the triangle? Okay, so the area of the triangle, since this is an equilateral triangle, Therefore, this is 60. And since we've created a perpendicular bisector here, this is 90. And this should be 30. Okay, guys? So we have a 30, 60, 90 triangle. And then we're given here 20. So if this is a 30, 60, 90 triangle and the hypotenuse is 20, therefore the smaller side, the one opposite of 30, is just equal to 10. It's just equal to 10 inches. So therefore this side, okay, let's say this is point X. So XA is equal to 10 inches. So how can we solve for the height? Okay, so therefore the height is just gonna be S square root of 3 for a 30, 60, 90 special right triangle. And we know that the value of S is equal to 10. Yeah, so that's the small side measurement, and this is just the big side measurement, or the hypotenuse. So that's gonna give us 10 square root of 3. So therefore, we know that the height is equal to 10 square root of 3, and we know that the base is equal to 20 inches for this triangle ABC. So therefore, the total area of triangle ABC, okay, the total area of that is gonna be 1/2 base times height, and we know that the base here, it's not equal to 10, so that's 1/2 of the base, but a total base as said by our given, and it's an equilateral triangle, so therefore this is 20 times the height, which is 10 square root of 3. So therefore this is gonna give us 10 times 10 square root of 3. So therefore the total area of triangle ABC is gonna be 100 square root of 3 squared inches. So that's the total area of the triangle. But what we want to find is the radius first. We want to find the radius first of this circle, the golden circle. And then after finding the radius, we need to solve for the area of the circle, of the golden circle that we have here. So that we can fit the flower pot in Baldo's triangular container. So this is gonna give us, since R is equal to 80 all over S, so this is gonna be A sub t all over S. So the A sub t here is gonna be 100 square root of 3 all over the value of S, and the value of S is just 1/2 multiplied by 20 plus 20 plus 20, since this is the side measurement of the equilateral triangle that we have. So 20 plus 20 plus 20, so that's gonna give us 60 divided by 2. So therefore, what's the total area? Okay, what's the total, this total semi-perimeter of our given figure here? It's 30 inches. So we divide this simply by 30 inches. And this is the radius of our circle. To solve for the area of the circle though, it's going to be equal to pi r squared. And we know that the value of r here is going to be pi times 100 square root of 3 all over 30 squared. And what's 100 square root of 3 all over 30 squared for this figure? Okay, so that's gonna give us 100 square root of 3 all over 30. Then we can square that. So that's gonna give us simply pi times 100 all over 3. And this should give us 100 pi all over 3. And what's 100 pi all over 3, guys? 100 pi divided by 3. So that's just equal to 104.72. Yeah, so therefore, what's the area? The area of our given figure of the circle, of the golden circle, it's equal to 100 pi all over 3 squared inches. Or if you round that into a decimal place, the total area of the golden circle is gonna be equal to 104.72 squared inches. And that's the answer for our problem. That's the area of the golden circle, 104.72 squared inches, or 100 pi all over 3 squared inches. And that's how we solved it.